Okay, ready?
It's recording.
Oh, okay.
I said okay.
Hi everyone, my name is Delilah, and I'm going to be teaching you how to solve this differential equation, which is number 2 on the worksheet we did in class. So immediately when I see that it's not a linear differential equation, I think Bernoulli. I think that's how you spell it. So what I want to do is isolate this dy dx. So I want to multiply throughout by y to the negative 1/2 to get rid of this one. So then I want to have dy dx plus 3 over 2 minus 1 over 2 gives me 2 over 2 is equal to y to the negative 1/2. Okay. So now that I'm here, what I can do is substitute u is equal to y to the 1 minus n. And so minus n is minus negative 1/2, which is plus 1/2. So then I have that u is equal to y to the 3/2. Or y is equal to u to the 2 over 3. From this, we can also derive that dy dx is equal to 2 over 3 u, and then you subtract 3 over 3 to get negative 1 over 3. Du dx. So now what I want to do is replace the dy dx replace the y, and because this is an exponent, we want to multiply these two. The 2's cancel out, so then I get u is equal to negative 1 over 3. So now what I want to do is isolate this du dx. So I want to multiply throughout by 3 over 2, which is the reciprocal of 2 over 3, so I can get rid of that too. U to the, and so if I add 1/3 to negative 1/3, I'll get 0, which would be u to the 0, which would be 1. So I will multiply by, the exponent will be 1/3. So I'll multiply throughout by that. So this will disappear, and I'll get du dx plus the 3 over 2, and then u to the 1/3, u to the 2/3, 1/3 plus 2/3 is 3/3, so u to the 1 is just u, is equal to, we said this was u to the negative 1/3, so now we have 3/2. 1/3 minus 1/3 gives me 0, so u to the 0 is 1. And now we want to bring this over to the other side. So we have du dx is equal to 3 over 2 minus 3 over 2u. And we can rewrite this as 3 over 2, 1 minus u for simplicity's sake. Once we integrate, it'll be a lot nicer. And then do a little bit of algebra to get du du over 1 minus u is equal to 3 over 2 dx. Okay, so we're ready to integrate. And this ends up being negative ln of 1 minus u plus c is equal to 3 over 2x. So we know from this substitution up here that u is equal to y to the 3/2. So we can do negative ln of 1 minus y to the 3/2 plus c is equal to 3 over 2x. And if I'm correct, I totally forgot what this problem looked like. If I'm correct, this problem has an IVP, so y of 0 is equal to 4. Let's go ahead and just figure out what c is now. So negative ln of 1 minus 4 to the 3 over 2 plus c is equal to 3 over 2 times 0. Okay, so this is out. So we get that c is equal to natural log of 1 minus 4 to the 3 over 2. So 4 to the 3 over 2 is the same thing as saying 4 cubed, square root of 4 cubed, which is the same thing as saying 4 square root of 4, which is the same thing as saying 4 times 2, so it's 8. So 1 minus 8 is equal to negative 7. But really, these are absolute value brackets because we're not dealing with complex analysis. So we'll pretend it's positive, and we'll say that c is equal to the natural log of 7. Because we had negative 7, but we'll just make it 7. So now we want to plug back into this one. Negative natural log of 1 minus y to the 3 over 2 plus natural log of 7 is equal to 3 over 2x. And this is the solution to our differential equation. See you next time. Bye.